Hello, Year 10 student. So today we're going to do 4.2, roots of quadratic equation. So what is root? Root is actually the value of x. The values of x of your quadratic. Sometimes, some quadratic, they don't have root. Sometimes they have only one root and sometimes they have two different roots. Okay, so let me show you example. So let's say we have one quadratic equation, y equal to x squared plus 4x minus 12. If we want to check the root, actually we need to find the value of x. Okay. So x squared plus 4x minus 12 equal to 0. Why equal to 0? Because to find the root, okay, of quadratic is where the graph intersect with x-axis. So intersection in x-axis mean your y is 0. So y is 0. So in maths before, we learn how to solve this quadratic. Okay, you have to factorize. So negative 6 mean times 6 times 2. Negative 2. Okay, then you get 4. So x plus 6 equal to 0 or x minus 2 equal to 0. So x equal to negative 6. X equal to 2. So x equal to negative 6 and x equal to 2 we call roots. So let's say you want to sketch the graph. Negative 6 here and 2 is here. And this is a positive graph. A is 1. So it's a smile graph. So you have your graph here. Okay. This is how you find root. But sometimes some quadratic they don't have root. So if we don't know either the quadratic have root or not, or maybe the root not in whole number like this, how we going to check? Okay, so how to check type of roots if you have quadratic equation? So let's say we have x squared plus 4x minus 3 equal to 0. Okay, how to check what type of root is this quadratic equation? So for your information, we have 3 types of root. Okay, first we call it real and distinct. Real and distinct mean 2 different roots. Means when you factorize your quadratic, you will get 2 different values of x. Second type is real and equal. So you have one root, then they are actually equal. Okay, and then number 3 you have no real roots. Okay, so the root are not real. This is we call it imaginary number. If we transform these two graphs, if you have real and distinct, your graph either, let's say smile graph will cut at 2 different places of x-axis, or if a set graph, they also cut at 2 different places of x-axis. Okay, if real and equal, they have root, but only one, means they just touch one point on x-axis. So your graph located on top of x-axis, or if negative graph, the graph look like this, they only touch at one point. Okay, if no real roots, your graph doesn't touch x-axis at all, either like that or like that. Okay, so we have 3 types of root: real and distinct, real and equal, no real roots. Okay, just now, how to check? Okay, how to check type of root? Very, very easy. We need to use quadratic formula. So, quadratic formula, you can see in your textbook, page 69. Okay, Quadratic formula, we use quadratic formula actually to calculate the value of roots. Okay, but by using this formula also, we can check type of root. So quadratic formula is negative b plus minus b square minus 4ac over 2a. This is square root. So to check type of root, we just need to use this b square minus 4ac. So b square minus 4ac, we're going to use to check type of root. Okay, we just use this. So what is actually ABC? So ABC is A is a coefficient of x squared, B is coefficient of x, C is constant. So let's say we have x squared plus 4x minus 7 equal to 0. Then we want to calculate the type of root for this quadratic equation. So from here, our A is 1, B is 4, C is negative 7, right? So to determine type of root, we have to use b square minus 4ac. So this we call discriminant. Okay, so substitute your b, which is 4 square minus 4, a is 1, c is negative 7. Calculate this value. So you get 16 plus 28, right? So 16 plus 28 is 44. So 44 is more than 0. So if your b square minus 4ac more than 0 means you have real and distinct roots. Okay, if you have b square minus 4ac, let's say you have another quadratic equation, then you use your discriminant to check, then your b square minus 4ac less than 0 means no real roots. The root is not real. You don't have the value of x. Okay. If you have b square minus 4ac equals 0, exactly equal to 0, means that quadratic equation have real and equal roots. Alright. Let's look at another example. Let's say we want to know type of root. Okay, type of root of this quadratic equation. So we need to use discriminant b square minus 4ac. Check either the value is more than 0, less than 0 or equal to 0 to determine your type of root. So from here, our a is 2, b is negative 1. Make sure if negative here mean that it belongs to your b, your c is 1. So substitute in your discriminant b square minus 4ac. So you get 1 minus 8 equal to negative 7. So your b square minus 4ac now is less than 0. Means this quadratic doesn't have root. No real roots. Means when you draw the graph, your graph doesn't touch y, doesn't touch x axis hanging. Okay, no touching. Okay, because they don't have real roots. Okay, let's say you have this. Then the question said calculate or find the type of root. What you have to do? So if you notice your quadratic equation not in standard form, you have to expand and make it in the form of ex squared plus bx plus c. Okay, so what you have to do, you have to expand first. So you have 2x squared plus 3x minus 2x minus 3. This is 5. This is must be equal to 0. So bring over the 5. You get this. Okay, simplify. 2x squared. This one is x. Negative 8 equal to 0. So now you already have in general form. Your a is 2. B is 1, C is negative 8. To calculate type of root or to determine type of root, use discriminant b square minus 4ac. Substitute your b is 1, your a is 2, your c is negative 8. So you get 1 minus minus plus 4 times 2, 8, 8 times 8, 64. You get 65. So this value is more than 0. Means this quadratic equation have real and distinct root. okay, this thing is actually different. So real and different roots. Means if you want to draw this graph, they will touch your y-axis. Sorry, x-axis. Okay, this one. Okay, so if you have any question, please tell me. I can video call you, show you how to do it. Please voice up if you don't know. Don't copy your friend's answer.